Hello, I'm Mr. Castillo, and I'm going to be doing the extra credit for test 4. So for the first question, it wants us to find an organic compound with 3 or more functional groups. We need to identify each functional group and identify the electron geometry, molecular geometry, and hybridization. So right here we have orotic acid, and we're going to be finding all the functional groups. So orotic acid actually has 4 functional groups instead of the 3 that we're supposed to find. I'm gonna just show off 4. So we have 1, and that's an amide based on the table. We have 2 right, so this is the second one, which is also amide. This third one is carboxylic acid, and this fourth one is an alkene. Now, since we have 2 different amides, we're gonna have to differentiate both of them just to make it easier. So we'll call this one amide A and this one amide B. All right. Next up, we identified all functional groups. Now, next, what we got to do is find the hybridization, electron geometry, and molecular geometry. So we got amide A. And in the amide, we have a carbon, oxygen, and nitrogen. So we'll have carbon, oxygen, nitrogen. So first we need to find the amount of bonded atoms and lone pairs in each one. Carbon has 3 lone pairs. We have 1, 2, 3. 3 bonded atoms, sorry. And it doesn't have any lone pairs. So we put 0 lone pairs. That makes 3. Oxygen has 1 bonded atom and 2 lone pairs. That's 3 as well. 1 bonded atom right here, and then it has 2 lone pairs. The nitrogen has 3 bonded atoms and 1 lone pair, which equals 4. Right here we have 3 bonded atoms, 1, 2, and then bonded with the hydrogen, and then 1 lone pair. Next, we need to find amide B. All right. So amide B, we also have an oxygen, nitrogen, and carbon. So with the oxygen, we have 1 bonded atom, and 2 lone pairs equal to 3. Nitrogen, we have 3 bonded atoms and 1 lone pair. It's equal to 4. The carbon has 3 bonded atoms plus 0 lone pairs. Doesn't have any lone pairs, which is equal to 3. Next, we want to find the carboxylic acid. So in carboxylic acid, we have an oxygen, carbon, oxygen. Now in the first oxygen, we have 2 bonded atoms and 2 lone pairs. It's actually supposed to be some lone pairs right here. Those are supposed to be 2 lone pairs so that it can fill up its entirety and have 4, a complete 4. Carbon has 3 bonded atoms and 0 lone pairs, equal to 3. Oh, this one's equal to 4. Oxygen has 1 bonded atom, has 2 lone pairs, equal to 3. Lastly, we have to do the alkene. So the alkene only has 2 carbons. Both of them have 3 bonded atoms and 0 lone pairs. My writing's horrible. Both of them are 3. So next we need to find, first we need to find the hybridization. So using the finger method, we know that this is sp2, sp2, sp3, sp2, sp3, sp2, sp3, sp2, 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 and sp2. Next, we want to find the electron geometry. Electron geometry is not the words, that's the molecular geometry, it's actually just the number. It's actually like molecular geometry on the side. So for the electron geometry, for the carbon in amide A, it's 120 degrees. The oxygen in amide A is 180 degrees. And the nitrogen in amide A is 107 degrees. Next we have amide B, which it's both of them since, in amide B, we have oxygen as 180 degrees. The nitrogen in amide B, 107 degrees. And the carbon is 120 degrees. Same as amide A because they're both the same. Next, we have carboxylic acid, which is the oxygen. The first oxygen is 104.5 degrees. The first carbon is 120 degrees. The last oxygen is 180 degrees. Next, we have the alkene. The alkene is, both are actually the exact same. Both are 120 degrees. Now the molecular geometry. For the amide A is trigonoplanar. For the oxygen, it's linear. And for the nitrogen, it's trigonopyramidal. Yeah. For amide B, we have the oxygen as linear. Wrote it in the wrong areas. We have the oxygen as linear. The nitrogen is trigonopyramidal or pyramidal, I don't know. Hope I spelled that right. That's an A. Third one, the carbon is trigonoplanar. For the carboxylic acid, we have the first oxygen as bent. The first carbon is going to be trigonoplanar. And the second oxygen will actually be linear. Now moving on to the alkene, we have both of them as the same, and both are going to be trigonoplanar. All right, and that's all of that for question 1. All right, next question, we have to find the 4 isomers for the 4 constitutional isomers for C4H7Br. Now, first we need to use this formula to find the amount of cycles. So we have, let's just write down C4H7Br. So the formula is as follows: 2C plus 2 minus H minus X plus N over 2. Now, as we can see, we have 4 carbons, 4 C's, plus 2 minus 7, because that's the amount of hydrogens, minus X. The X is actually the halogens that are in the chemical formula, and bromine is a halogen, which makes that minus 1, plus 0 since we have no nitrogens, over 2. That's just 2 over 2, which is just 1. So first we have the first one where N equals 4. So we have C4H7Br. So let's write it down in the square format. But remember, we still need to have the bromine. Bromine, we'll put it right there. This is the bromine, sorry. So let's just make sure we have the right amount. So we have these each have 2 hydrogens. So that's 2 hydrogens, 2 hydrogens, 2 hydrogens, 1 hydrogen, which is 2, 4, 6, 7. So we have 7 hydrogens, 4 carbons, and the 1 bromine. So this is a correct one. Now we need to figure out the name to see if to find the name. We're not finding difference in the other names.